Hi everybody, welcome back from the video where you were shown a little light bulb guy talking to you about what I would call some safety on electricity, right? Now, what can we learn? Okay, conserving electricity or electrical energy. So you can see the word here. Okay, this word is actually the same as so electricity is just another word for the term electrical energy because it's a form of energy. What other forms of energy do you know? Okay. Right? So this is just another type of energy. So when you call it with the term with the energy at the back, we say electrical energy. We don't say electricity energy. But if we call it just electricity, is fine as well. Okay. Right. So shall we start a little bit of summarizing what our friend Bulb said earlier, and then we do the questions, we will realize what this lesson today is about. Okay, so in order to summarize, we need to pick up on what he said and try to fill up the blanks. So as usual, please help me. Okay, it's not as easy as all the previous weeks. Okay, finally this one is one tough one. So this time you really need to crack your head. The previous times is just too easy. You just close your eyes, you can do. Now you can't, because you have to think through what is this letter C, what is this letter C, what is this. You need to know what renewable resources, non-renewable resources, natural resources, what they are. So those of you who have read a lot, know a lot in science, you know about energy, then you can help me. Come, let's help me. Type for me the first 4 blanks on your chat right now. I have no idea, says Revan Anthony. It's okay. The ideas all will come to you slowly, slowly, slowly. And very good. Brian, thanks for natural. Brian answered natural. So I'm copying Brian's answer down. Electricity is usually produced. Okay, just now we saw our friend trying to tell us where does electricity come from. We saw it's released from some kind of industrial place where electricity is generated. It must be generated with some kind of other energy. Usually is in the form of kinetic energy, like a dam, and then that energy changes to electrical energy, first to heat energy, and so on. So there's energy conversion. So energy cannot be created, it can only be converted. So you must have a source where it comes from. Okay, so there is another chapter where we will consider the energy sources and the types of energies. That's for another day. Today we only talk about the electrical energy part, the electricity part. So we focus on this one. So we say, where is it coming from? Okay, natural resources, crude oil and coal, you can burn them. So that's where they come from. That's the source. So let's go back to the source. So I can do this. Okay, how many sources are there? 3 sources. What are the 3 sources? Well, it's written down here: coal, crude oil, and natural gas. These 3 sources, right? You have to know for your entire life. Okay, no matter how old you get, people will still be asking you, where does electricity come from? Electricity come from? Where does electricity come from? It comes from natural gases, coal, and crude oil. But these resources, right, are natural, but they are not infinite. They will not be there available for us forever and ever. That means they are non-renewable. Okay. This term non-renewable means they cannot renew itself and get more and more and more. One example of, so what is renewable then? What is renewable? That never ends. So always you get more and more and more and more. Okay. Air. Okay. Air never ends. We cannot find a situation where one day we use up all the air and then we are going to start buying air from somebody. Can we do that? Air is natural and it exists all the time for eternity. Somehow we are thankful for that. Similarly, water, not really water and saying water, clean water, but seawater. Seawater also, no matter how much you take, is always there and there and there. It's renewable. That means I think even if you start taking home all the seawater in the world, how long will it take? Okay, let's say it takes you 500 million years. Even after that, there's still water there because it's a natural renewable resource. Somehow some being is there. I think for me, maybe God is the one, but for you, you don't believe in God, it could be anything. It could be science. So behind science, what we call is the renewable resource. Okay, so air and seawater are examples of a renewable. That means no matter how much you breathe, how much you use, you will still have it back. So it's okay to use air. For example, you want to go and blow dry your hair. You can use air, right? Like normal air. Like you just come out of the shower, you stand there for about 10 minutes. Okay, done. Your hair is dry because you got air. And you also got the heat from the sunlight and you still got light. These are all natural also. Renewable. Sunlight is also renewable. It never ends. Oh, so I can put sunlight. So one form of, very good. However, if you use a hair dryer, then indirectly you are using electricity to on your hair dryer. Therefore, that's not the same as you using or standing in air like me. Okay, so you versus me, I stand in air. I just stand for, maybe of course I will stand for longer, but my hair will eventually dry after shower, right? But your hair, you want it to dry immediately, so you start powering up your hair dryer with electricity. Where it comes from? It comes from the wall where there's electricity already existing. How do it come? From somewhere. It's just passing through to your wall where you just connect your plug, is connected. So that somewhere is going back to the industries where there is a source, and then we have to find back to this, go back always to coal, crude oil, and natural gas, which are actually available in our land, okay, like under the earth. So we take it and start burning it, and we start getting some kind of energy. But we take and take and take, one day it will finish. So one day it will finish. That is why it's non-renewable. So we got to be careful on its usage. So it looks like so far we have been using a lot of electricity, I'm sure, from the time when the first man set foot on Earth billions and billions and years ago, right? Or millions of years ago. So one day we're going to come to an end. So we have realized this through the study of science. So what do? We find for other sources where we can create energy, we can create electricity. Okay. So the faster we use these natural resources, the faster they run out. Okay, they run out. So what do we fill up in the two blanks after that? The big W word. We cannot waste electricity, because if we waste electricity, we are wasting these natural resources. It's directly related, right? That's why I said, if you are using your hairdryer at home, you're using electricity. You're using electricity, you're directly using these natural resources that were available before, like your gas, your coal, and so on. You're using them up. So you are one of them who uses up. I'm one of them who uses up. Everybody is using it up. And then one day we don't have, then we're like, I don't have any light at home, no electricity, that's it, bye-bye. So humans have to think of new innovative ways. That's why scientists are for. We try to figure out how can we stop depending on this and create electricity with some other ways. So there are ways you can create electricity. You know, like if you have heard of a bicycle, of course you have heard of a bicycle. Then it has a lamp in front of it to light up at night. But it does not, your bicycle is not charged. It's not connected to the power socket yet. the lamp can light up? How? Okay, you think about this. We try to discuss at the end of today's lesson. Okay, maybe some of you will already have answers, but think through how come the lamp can light up. Of course, there are some wires, but where is the wire connected to? Where is the wire connected to? Those wires that you see that are very visible are not your light wires. Those are your brake wires. Okay, those of you, don't confuse yourself. Okay, some of you already gave me answer is battery. Okay, yes, modern times we do use batteries. Batteries is another way of creating electricity without, is it killing off natural resources? What is contained in the battery? Okay, so Abhinand Ram, thanks. Yes, that's the correct answer. Battery does power up your lamp. But let's say my bicycle, I have a bicycle and I have a lamp, and I can use my lamp all the time, and I don't use a battery because it doesn't have a battery box. So, and then because it doesn't have a battery box, that means my battery will never run out. That means I can use my light forever. So how do I create that light? So think about it, and we'll talk about it at the end of the lesson. So how can we conserve electrical energy, which means to save? Okay, conserve. Many of you may have seen this word, but it actually simply means save. Okay, save. How do we save electrical energy? How do we save electricity? So a lot of things, when they ask you in your question paper, they may say the same things. Okay, like use another term. You see, this is electrical energy, this is electricity. I use two different terms, but it's the same answer. You save, you use conserve, same answer. Question is different. So we can try and catch you. You may go and find out, hey, I have learned how to save electricity, but then in the question paper, you find it, hey, what is conserve electrical energy? I don't know. I haven't learned this electrical energy thing. Oh no. But one fine evening, one fine afternoon, Mr. Ali on 18th of June 2020 told you that saving electricity means conserving electrical energy is the same thing. Okay, let's fill up. Help me. Some of you have already helped me before. Those of you who have not participated, okay, I don't need to hear a voice today. If you are shy, it's okay. Never mind. Just type the answers so that we can see how many of you participate. And of course, I can just say, hey, thanks for the answer. You're helping me. Okay, Jimika or Jamika? Jimika, surely Jimika. Okay, see, we've got interesting names. Help me on this one. She helped me. I hope it's a she. If it's not a she and you're a he, you can just type, say, hey, I'm not a girl, I'm a boy. Okay. Turn off all electrical appliances when they are not used. Thanks. Okay, this is like what? A closed passage, your English closed passage. Yeah, but with a little bit of extra help because you got the first alphabet already. Then use what bulbs as they use less electricity? How do you use? What kind of bulbs do you use? There are energy saving bulbs versus bulbs that take up a lot of energy. So what happened is, in the past, we just, this person who created light, who knows the inventor of light? We know the inventor of light. Do you know the inventor of the aeroplane? Do you know the inventor of light? Without him, we would not have ever had light. So Hedwin Lim, thanks for your answer. Hedwin Lim. Do you want to tell the whole class who the inventor of light is?
Thomas Edison.
Very good. Thank you very much, Hedwin. Thomas Alva Edison is the inventor. If you read this life story of a lot of scientists, they actually did not do very well in school, but they were very, very smart because they actually like to play with toys, like all of us, right? We all like to play with toys. The more we play, the more we learn. So if I gave you toys like bulbs and batteries, they're going to be so eager to work with batteries and bulbs, and then you actually figure out, you can actually teach your parents and teachers how to play, just like how you teach them how to play some of the apps on the phones, right? I guarantee you know how to play a lot of games on your parents' phone, but your parents don't know how to play the games on their own phone. Why is it so? Why? Because you play them, you figure it out, you know it, you become the expert. But your parents don't play, they don't know it, they don't know anything. That's why. So similarly, in science, in math, if you do it, you play with it, you become the expert, you can teach anybody in the world. So the more you get your hands on it, the better you become. Just remember about the app, the games that you have on your phones, on your parents' phones, whatever. We get better and better as we play. So Thomas Alva Edison, he did not do really well in school, but he was very good with physics, science, and stuff like that. He did a lot of experiments to finally figure out with electricity, he can connect some filament and make something heat up. And then suddenly, wow, there's light from this. Then he could see in the dark. Oh, I think if I remember clearly when I was a young boy, I read the story was like, I don't know if it's a true story, maybe you have to research on this, but it's like he tried to study, but in those days when there was no light, right? At night, there's no light. So what people do is usually by the only light source was the sun. So what people do is when the sun sets, it becomes dark. As all of us know, this universal truth nobody can change. Even during Edison and now is the same. When the sun sets, it becomes dark. If not for the light, we will all live in darkness. So we cannot see our kitchen, we cannot see our table, we cannot see each other. What do they do? Who knows what they do? And Edison hasn't discovered the bulb or the light yet. What did people do before he discovered it? Okay, they could use fire. Yes, very good answer, Abhinan. Very good. One way is fire, but if you are living in the forest and you have the woods and you have all the facilities to create heat, yes. Okay, candle as well. Sophie, thanks, Sophie. Candle as well. So we use candle and all this. It's very, very difficult to do. So let's say Mr. Ali is very, very lazy. He don't want to start a fire. He don't want to start a candle. Go look for candle. Suddenly, I cannot find my candle. How? It's so dark. I cannot find the candle to light up my candle. Light when I can't even find my candle. So what I do, I'm very lazy. So what do? I go to sleep. I see my bed. I see it's nighttime. Okay, thank you. I go sleep. Good, because I sleep at like, okay, sunset, right? 7 o'clock. So you can actually wake up what time? Actually, dawn is around 4:30, 5 o'clock. There's a little bit of light. The actual sunrise about 6:37, 7:10. You can see full light in the whole sky, on whole earth, wherever you're living. But by 4 o'clock, we call this other word called dawn. What is dawn? Dawn versus sunrise. How many know the difference between dawn? Have you heard of the word dawn? Some of us have friends who are called dawn, D-A-W-N. What's dawn? Dawn is when the first line of light it appears on our sky. Okay, the sun is rising, but we really haven't even seen the sun, but his light has appeared already. So when his light appears, we call that dawn, and that usually happens around 5:30. Okay, so that means I can wake up at 5:30. So I sleep from 8 to 5. It's about a good 9 hours. So I got my 9 hours rest. So I'm sleeping at the correct time. What do we do nowadays? Now we have light. We just switch on the light. We stay up to midnight. Okay, blah blah blah. We do all our things. Like we want to watch TV. All the light is helping us become a nonsensical human being. Okay, in the past they were probably much healthier. They slept at the right time, woke up at the right time. Because you wake up, you have light again. You can do whatever you want. But instead of waking up at the time of light, we sleep through, especially on weekends, from 5, 6, 7, 8, 9 o'clock. It's so bright, we're still sleeping because we use so much energy at night to stay awake. So in the end, what happened actually? Who didn't benefit? We, because what happened was at night, I started switching on my light for extra 4 hours, which means I pay for it, which means my pocket money goes out to the electricity company. So you see who's going to not benefit by staying up. So you see all these things. We can actually try to go back to that lifestyle, but it's so hard, so difficult. Okay, try. But of course, children, as you guys know, when you were younger, like 3, 4 years old, you did sleep right after dinner, right? 8 o'clock. Now it's so difficult. Why? Too much homework, right? Okay. Carry on. Now, enough of those stories. So we talked a lot about the saving the electricity and all that. Okay. Why did I even talk about the sun? I can't even remember. But you guys, I think it's because of Thomas Alva Edison. Yes. Thank you. Finally. So Thomas Alva Edison is the discoverer of electricity. How he found it, you can go and find out the story. Actually, these stories are also interesting. I know you like to read storybooks of Harry Potter and all this. These are called fiction. Fiction means a story made up by somebody. You can also read non-fiction, which is a real story that happened. You can read story about Lee Kuan Yew, you can read story about Thomas Alva Edison, about Einstein, anybody who entered Newton and so on. Okay, you can read story about Mr. Ali, how he grew up, where did he study, how did he become a science teacher, where did he teach, which primary school did he teach before, maybe are you from that school before? There you go, research, right? Okay. Of course, a lot of you are eagerly giving me the answers to the final one. Instead of a fridge, instead of an aircon, you use a fan. Now, how do you deal with it? You'll be like, of course you're going to complain to me, say, "Cher, of course fan is so hot. I wish I had an aircon." Okay, some of us aren't even blessed with air conditioners in the houses. Guaranteed. Okay, it's not a given that we must have air conditioning just because the Singapore is so hot. We think everybody's houses have aircon. Wrong. Okay, not everybody's houses have aircon because it's an expensive gadget to put and it costs a lot of money to cool the room when a fan can do the job. Okay, now where is one example? You may think, oh, of course there's aircon everywhere. My house has aircon, a shopping center aircon. If I go by the bus, aircon, MRT also aircon. Good. No, our classroom doesn't have aircon, right? So what happened to our classroom? How come our classroom doesn't have aircon? Yeah, we should have aircon from our classroom. Maybe not. Maybe we feel that that's just too much waste of energy. But if you ask me, I think we are wasting a lot of energy anyway. Why do we need to give air conditioning for the whole of Suntec City, the whole of Vivo City, right? How much air conditioning is being wasted there? And then we can't even give aircon for our own classroom, which is a small place, which will give us comfort and we can study well, especially now when we're wearing masks, right? So it's a question worth pondering in your mind. So these are science questions that you should ponder as a science student. We are only, in P5, P6, but you can start thinking about this because invention and questioning is not age bound. You can ask questions anytime and you can start thinking about a problem and solve the problem. Then you become an inventor. We have had many young 12-year-old inventors. If you go search the internet, like I said, Thomas Alva Edison, Albert Einstein, all the scientists and politicians, all of them have a backstory where they start young as a child. Okay, so you can also go and Google youngest scientist in the world. What did he discover? Blah, 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 blah. Okay, then it'll be interesting, right? Maybe it relates to us. Not Harry Potter. Harry Potter is not science. He's fiction and his magic. It's nothing to do with science because he actually go against all the science. Because science says human beings cannot fly. He can fly. Is he can fly? I don't know. Or he cannot create fire just like using a finger, but he creates. So that's magic. That's fiction. That's a story that you write. So if you are a storyteller, then you can't be a science person. Understand? All right. Okay, that's beautiful. Thanks for all the help. And also we discussed something we needed to have before we go to the questions. Okay, we go through the questions, then we understand better. Study the circuits, and the clue is the bulb in circuit 2 lit up, but the bulb in 134 did not light up. So circuit 2, I'm going to do like this. So this is a question on conductors and what? Insulators. So if you have a piece of object, okay, a piece of object, it can be a metal or it can be a non-metal. A non-metal like rubber, glass, wood, plastic, and so on, cannot have electricity going through them. So therefore we call it insulator, something that doesn't allow electricity to flow through. So we say that no electricity can go through. But for conductor, electricity can go right through it, so it can conduct electricity. So in this question, because the battery is connected to two objects, X and Z, that means X and Z are conductors. So let's say green. I tick. Okay, X and Z are conductors. It helps to light up the bulb. Whereas the others, Y and W, are non-conductors. Okay, so Y, so let's use a W is gone, cannot. Okay, Y and W. And you look at circuit 1 and 3, as long as even if you have one that does not allow and you have one that is conducting, it still doesn't allow because it's blocked, right? You can see it's blocked, right? So only one light is light bulbs. If the rest, like circuit 4 can light up if there is a conductor. So there are only two, right? Am I right? Because the others does not light up. So you have to base on light up. Because if Z, look at circuit 3. circuit 3, Z can conduct, yet it doesn't light up. That means Y does not allow. So Y is not allow. X you know can conduct, but W doesn't allow. So W is not a conductor as well. Therefore, answer is, which one does? Is insulator. They're not looking for conductor, so it have to be B. Got it? Some of you say A. Why do you say A? Because you thought it's conducting electricity. Am I right? This is insulator you're talking about. Does not conduct electricity. How many of you are still confused? Put up your hand or let me know. Then we can go through it again. Okay, answer is B, not A. Okay, because I hear some of you students like Brian, Jimika, and all say A. A, X and Z is a conductor. Okay, so let me write down. Maybe because you didn't read the question. The question says it's an insulator. Insulator means non-conductor. So go opposite. Understand? So those of you thought A is a conductor and B is non-conductor. And non-conductors are called by another name called insulators. Okay, take note of this and then you're fine. All right, very good. Okay, Aina constructed a circuit as shown in the diagram. It's a little bit small, cannot see, right? Never mind, I will blow up the picture in a while. But she constructed electric circuit, and then look here, it becomes more complicated than our last 2 weeks. Last 2 weeks, we just used battery and bulb and that's it, and wires. Now we have so many batteries, so many switches, a few bulbs, and some materials in between, like A, B, C, D, some materials, or A, B, C only. A, B, C. Okay, I'm going to color for you. Then you can see what are these. This A, B, C, right, are what? Some objects, see? Some objects were placed at various points A, B, C. Understand? So I'm actually looking at this line here. So these three things are objects. Now we need to determine if these three objects can let electricity pass through or cannot let electricity pass through. If can let, then it's probably a metal, something like a conductor. If it cannot let, then it's an insulator. Okay, so that's how we need to identify. And Aina doesn't know. Okay, so what does she do? These objects include metal pins, rubber bands, and matchsticks. So it could be one of these three things she had. So she put them there. Then Aina closed the switch and let the electricity run. And she needs to know if this bulb light up or not. There's only one place where she knows electricity is arriving or not arriving. It's going through or not going through. Where is it? The ultimate testing guy is the bulb. So I'm going to color that as a bulb. So is it light up or not light up? Okay, it only lights up. Okay, so the question here, let's read up. See where I'm circling. Did the bulb light up? No and yes. Yes, let's look at yes. It light up when where? When S2 and S3 is closed, which means, okay, let's draw the S2 is closed, S3 is also closed, and it lights up. So this is what? This is the circuit. So all of you follow the diagram. Go up to the diagram, see the red line. Then you see that S2 and S3 is closed, it lights up. That means confirm that A and C is in the path, and A and C cannot be a rubber band, cannot be a matchstick. It must be metal pins, right? Because the light did light up. You understand? So I'm only looking at this statement here. You see the star where I'm putting? Where am I putting the star? This statement here. The statement here, where there is a star here. I'm only reading here. She closed, and then that it did light up. So that therefore it tells me that A and C, the identity tells me that A, electricity must be passing through A and C. So can it be rubber band? No. Can it be, what's that? Matchstick? No. But it can be metal pin. So A and C can be metal pin. So I go to the answer. I circle metal pin. A can be a metal pin. C also must be a metal pin. No other way. It cannot be a rubber band. It cannot be a matchstick. Right? So that's how I identify. Now, since I still cannot find the answer, is it A, B, C, or D? I need to use the other information. So let's go to the new star. Can you see the new star on the left-hand side below? I'm going to draw now. 1 star, 2 star, telling me that I will close S1 and S3. So let's look at that. So what happens is, look at that, go up. Let's close S1 and S3. So it should be like this and this. So the electricity goes here, goes here, goes here, and goes here, and doesn't go up. Why? Because S2 is not closed, it's open, so it can't pass through C. So C is taken out of this circuit by just not closing the switch. So there's no way electricity can run through to C because the circuit is not going to be complete and run through. Now, bulb A did not light up. What does that mean? But we already found what is A, right? What is A? What is A? A is a pin, a metal pin. So A, no problem. So you should allow the electricity to pass through. But B, did it allow? Because the light did not, or the bulb did not light up. So B, something wrong with it. So we can identify that it did not allow. See, do you see the break? I take away the red line. That means electricity cannot run through. So something wrong with the B. So B must have been rubber band or matchstick. Can? Okay, so I think you already know the answer is B, right? Why? Because there's only one answer which gives A and C to be metal pin and B to be a non-metal or non-conductor or insulator. So it could be, yes, like Abhinan says, it could be rubber band or matchstick, but in our answer, we need to match, right? Look at the matching. We need to figure out, should we choose B? Should we choose C? We cannot choose C because of A, this one. This one cannot be here, right? It should be a metal pin. And D we cannot choose because this one should be a metal pin also, so we cannot. That's why we should choose B, because B gives us the best answer saying that A must be metal, C also must be metal. B can be either one, but thankfully they give us one of it. It could be rubber band or matchstick. Even if they change rubber band, no problem. It's the same. Okay, so there's only one option here, no other way. Get it? So now, after figuring it out, how everything works, electricity and all that, can I ask you one question? Okay. If you notice that once I identify, all of you please focus your eyes or your attention to the diagram. Okay. So I'm going to make the diagram big. Okay. This would have been much better earlier, right? Okay, then I make the diagram big. How is that better? So when the battery is positive, right? So let's use a red color or yellow color. Red color. Okay. So the battery, which one is positive? The long one is positive. The short one is negative. And there should be two, right? Because there are two batteries then. So where does the electricity go? This way, right? From the positive. And since the switch 3 is closed, I will make it like that. It goes there, goes through the bulb, and then its journey must complete, must come back here. Can it come back here? Which is the negative. It must reach. So it must have a path. So it goes here, it checks. Okay, just follow my arrow, my coloring. It goes here, it checks. S2. Hey, S2, I can't go back there, right? So that's why it won't go in. So you say, tada, see you later, C. I can't give you any power. I can't give you energy. I have to go to B now. And then go to B. B also cannot allow anybody in because who is B? B is after all a matchstick. Remember? He also cannot allow. So what happens? It just stops here, right? Cannot go through. So it says, that's it. So that's why the bulb will not light up. Okay? But the electricity can not move at all. Actually, the red line shouldn't even happen. The battery already senses that there is a path or there's no path. Okay? That means, you haven't actually driven. Let's say you are going to, let's say you're going to Vivo City and there's a roadblock somewhere. You don't actually take your car and drive all the way to near Harbourfront and then find out there's a block and you can't go to Vivo City. That is too late. The battery is so stupid that it had to go all the way and find out it's blocked. Okay, that's what I drew here because there's a red line already. So it's wrong. There should not be any red line. You know what it does? It just checks its GPS. Based on the GPS, it says, hey, S2, I cannot go in. B also, I cannot go in. So therefore, I will stay at home. Therefore, it will stay at home. You won't even have travel. So the misconception many of us think is electricity will flow. Electricity will not flow if there is no closed circuit. Okay. So you will not leave your house until you know the roads are clear. So you can check from home. No need to drive all the way to go and check. Okay, that's what the battery is. Okay, the battery is its GPS. It knows where is closed, where is open. The moment it knows it's open, then it will flow. That means it says, okay, I can go home and I can come back. So let me take my car and I'll leave. Okay, it'll get dressed. Very interesting. Very interesting. Very interesting. Okay, so this is a misconception that you may not have heard from a science teacher or from textbook. It's very, very hard to think through, but I managed to try and discuss this and also enlighten you guys. Hopefully it helps you there. Electricity will not start because the moment you start means you have wasted, right? Haven't you wasted your petrol? Am I right? If your GPS says is blocked and you cannot get to Vivo City, you already wasted your petrol going all the way to Harbourfront. Am I right? So you wasted your petrol. So that's why you cannot waste your petrol. It's wasting the fundamental rule for the battery and electricity is not to waste it. So it must use its GPS intelligence to say, okay, I will not waste it if I can't get back home. So it wouldn't go at all. Okay, so there's no electricity in the wires. So if you feel that, so that's why when you touch the wires, even if they are bare, there's no rubber, it will still be safe. Why? It hasn't even started. Nobody left the home, so it would be safe. Okay, so that people think, hey, can I touch the wire? Even though it's disconnected, even though open circuit, you won't. Some students may say, oh, there's halfway electricity going there already. Cannot. There cannot be a halfway electricity. Okay, fine, great. Okay, that's what I wanted to discuss and get out of that. Okay, let's go. Which of the following statement explain why we have to use electricity wisely? Okay, this is a no diagram, nothing. Just need to know what is that. Use your sense, use your common sense. You should know already. Okay, why do we have to use electricity wisely? Is the same as why do we have to save electricity? Okay, that's why I said at the start of this lesson, you can change the question in any way. It's the same. Why do you have to save electricity or why do you have to conserve electricity? Okay, same thing. Why? Because generating electricity is costly. Yes, you need to go and do a lot of work in the industries, make it convert, blah, 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 take natural resources, burn it. All this is costly, costs money. Otherwise, we can have electricity for free, like air. Does anybody charge you for air? No, because air is renewable, it's available, nobody can charge you. Nobody can ever come to the classroom and say, especially your friend sitting next to you, hey, you know what, today I will sell you oxygen for $10. You want to know? You can breathe more. Would they say that? No, if he says that, you say, crazy. Today, oxygen is free. I can breathe anytime I want. Because you know that it's sensible, it's common sense because it's available, it's renewable. But when something is not available, then it's costly, then people sell it to you. That's why we buy electricity, okay? So it's costly, definitely. The supply of fossil fuel is unlimited. Hello, it's not, it's limited. This word un is wrong, okay? It's limited. We will finish using them. So this is a wrong statement. This is false. Fossil fuels cannot be replaced easily. Yes, they are not renewable. So it's true. This is true. And lastly, burning fuels to generate will give off harmful gases. Yes, also, because anytime you burn anything, right? You burn anything, there's always gases, and these gases are harmful, which we just release into the air like nobody's business. We just don't care. But of course, indirectly, it's affecting our own lifestyle. We have a lot of carbon dioxide in the air. Carbon dioxide causes global warming. We get very hot. We say very hot, very hot, very hot. We complain so much. Do you know why you complain so much? You, not you, but all of us human beings are the one burning, using electricity, leaving our aircon on, fan on 100 times. You leave your room, you leave the aircon running. For what? You are burning and burning and burning. The more you burn, the more the gases are being burned, the more the gases are being released. Then, of course, you feel hot outside. Come on, the earth is not your home. The earth is your home, but you have to take care of it, right? You don't take care of your home. You just destroy it because you think it's not your home. They won't take care of you back because all these greenhouse gases, like Abhinan says, greenhouse gases, they accumulate. Then it becomes a very, very hot place. And therefore, we feel the heat and say, very hot, very hot, very hot, we complain. If you never understand science, we never went to primary 3 to 6, right? We didn't learn science, we don't know all this. So how are we going to ever change things? We're going to continue the same way? Are we going to continue burning forests? What people do, people who never learn science. In Singapore, we are very, very gifted. We go to school, right? So there are a lot of countries that are underdeveloped. They don't have facilities to go to school, or they are too poor to go to school. What they do, they straight away go into farming. They straight away go and be a construction worker or try to build things, something. They got no education. So they don't know that when they clear forests to build a house, they are burning the trees. The trees have been a source of oxygen. And then when you burning causes a lot of harmful gases, you release heat, and all this they don't know. Because they didn't go to school. They never learned what science is about. Okay, but you are lucky. You know all this. So you're going to help us save the world in the future. True. So therefore, answer for number 3 should be C. Okay, this is a kind of question that you might come across. Those of you who have done electricity, I heard that some of you have just stepped into the topic electricity, right? Especially if you're in P5. P6, no problem. You've already done this last year. By now, you're already preparing for PSLE. So you should know what this is. This is called a circuit card. A circuit card is where you have 4. These are all paper clips made of metal. 4 of what these alphabets are all, these triangles are all metals. Okay, so let's just focus on the metals. A, B, C, D are metals. 4 clips, you can see from the question. Now, if these metal clips are connected, then you can have electricity pass through from point A to point C, but it can't pass from point A to point B. Say, for example, let's look at D. Let's look at D, okay? Let's look at D. D, A and C connected, B and D connected, but no other connection. So electricity cannot pass through from B to C, cannot jump. There needs to be a line. Okay? These lines are also metals. Okay, so now we draw those lines. So all those in red are connecting metals. So if you take a battery, okay, and you start connecting here, and you start connecting, let's say there's a bulb here. Bulb, you know, this is the symbol. Or you want me to draw it in another way? Okay, you can also draw it this way, right? Okay, let's connect to D. Now, do you think this bulb will light up? Now, this is the fundamental way to check. Okay, so this bulb will not light up because B and D are not connected. They are not connected through that red line. Okay, only the red lines, not the black line. The black lines is just the board, it's a cardboard. Don't bother about the black line. Don't say I can go on the square. It's not the square, it's just a board. Okay, so I'm only looking at the red lines. If there's no red line connection, then it can't go through. Okay, so here you need to do a testing of clips. A and B were connected. Now in this case, this is called B and D were connected. Okay, B and D were connected. That means this one. Can you come to the star here? When B and D were connected, it actually lighted up. Oh, that means C cannot be. Okay. Here can, B and D can, because B and D are connected. Here B and D is not connected, cannot. Here B and D connected, can. Okay, so we must have only answer is A or D. Now, how to find another set? We got enough data on the left hand side, so we find another one. Say, okay, we only need to look for between answer A and D, right? So let's look at all these one that I'm circling. Which one lighted up? Okay, let's look at A and let's look at the star here now. A and D, it lighted up also. So for here, A and D connected. This is a correct one. A and D, this one wrong one. A and D must be connected. Here not connected. Must be connected. Here not connected. I got one cross already. That means D is out. A is the perfect one. Okay, A is the perfect one because it matches the data. So we want to confirm it. Okay, so let's put a new star. Let's look at A and B. So I'm going to tap the new data. If I connect A and B, it should light up also. Let's look at A and B. Here, is A and B connected? Yes. How is it connected? It's going to D and coming back. Can you see? It's this way. So it is connected. Can you see? So when you touch A, when you touch B, they are connected by the yellow lines, right? So it is connected. So that's why A is the correct answer. An experiment is set up as shown below. The bulbs light up when the metal plates are put in liquid. What does this experiment show about the liquid? Now, again, remember, it will check its GPS, and its GPS, okay, of course, there won't be any current, but I just draw so you can see. Its GPS must go, if it knows that it must go this way, it's going to check on the phone, the map. It must go here, then it must go here, then it must go back, go to the bulb, and come back home. It must come back home. You cannot come back home, you won't go anywhere, right? So, but he don't know whether he can jump from here to here or not. To jump from here to here, he is inside what? His surface is this. So this part must be electrical conductor. If it's not, then how can he travel? It must be made of metal or some other electrical conductor. It's not metal, not necessarily metal, but here liquid. So it can be a liquid electrical conductor. There are liquid electrical conductors also. For example, salt water is an electrical conductor. Mercury is an electrical conductor. So there are examples. So let me write it down. Some of you may have thought, hey, how come suddenly now liquid also can be electrical conductor? I thought it's always only metals. No, there are some liquids as well. Gases, no, but liquids there are, because of the ability of electrons to swim inside this liquid. So salt water has electrons or ions. Okay, you will learn more about this, but you just know that salt water is an electrical conductor, not just water. Just water is also actually electrical conductor, actually, right? Yes or no? But many of you learn that water is a very good electrical conductor, so don't have your wet hands touching electricity, because that will conduct. Yeah, Binan, very good. So salt water or just water is fine. So it could be water. But salt water is better in this type of situation where you want electricity to pass through to actually light up a bulb. So you actually create more energy flow by using salt as a dissolving salt in the solute in the solvent. So salt and water, and then you can have like mercury as well. This mercury has this property of conducting electricity. So liquids can. For those of you who are here and thinking only solids can, no, liquids can. So Hedwin, I love your periodic table. Very nice. All of you, if you can see people's videos, Hedwin is sharing with us a lot of things. Thanks, Hedwin. You have nice images. Was it you or your parent helped you to save all this? You have done it yourself? Really, congrats. Good. Okay, you'll be learning a lot of science, I can see. Okay, so this liquid must be an electrical conductor. That's it. So which statement here A, B, C, D says? Otherwise, the GPS says no go. Cannot go anywhere. Cannot go Vivo City. So now must go Vivo City. Vivo City, then you need cannot block. If it's blocked, if it's rubber, if it's plastic, glass, cannot. So it need to be a conductor. So it can be a metal or it can be a conductor that you know of. So here they never say it is mercury or salt water or whatever, but they tell you that it must be a good conductor of electricity. The rest says heat. It says good conductor, but it says heat. Here it says poor, which shouldn't even be. Here it says non-conductor, also shouldn't even be. So I think all of us know the answer really. After Mr. Ali talk and talk, of course his talking must lead to the answer, right? He talks so much on the left hand side, on the right hand side, he makes easy for the students to find the answer. Okay. Okay, this is my last MCQ question. After this, I will close the lesson because we don't need. So if you want Revanandini, you can just stay for this question and then you can leave. Those of you who want to leave also can leave, because this is the last question I'm going to discuss. Because today's lesson is over, as in we need whatever we need to know, we know through questions and also videos and also notes. Okay. Anything else? You go to the website tonight, tomorrow, download the answers have a look and work through the questions yourself. Of course, you know you have a lot of assessment books already. So you can straight away jump into the electricity chapter and do your own things, okay? Which of the following statements contains correct safety precaution when handling electrical appliances? Another common sense question. You don't even need to go to school to know this. As long as you're above 10 years old, you know already, because you're teaching your younger siblings this as well. I say, don't touch the electricity when you're with the wet hands. Don't put too many plugs. Why put so many plugs? You can cause a fire, you know. Okay, you have become an adult already, right, you guys? So you know better. So you've been teaching your younger siblings. Repair or replace exposed wires. Any exposed wires, you know, wires that are like showing the cable inside. Actually, the wires in our homes are all looking black because they are the black rubber or the white rubber. Inside should be a metal. Usually is copper. We can't see it because we are using that rubber to protect our hands. It's insulated. However, if they're exposed, then it's not insulated, right? That's the two different. It's insulated with rubber, but this rubber is destroyed or some kind of burn or something, that little part. So it will expose the wire. So that's what's called what? Exposed. When it's exposed, suddenly you cannot go and touch because there's a lot of energy and heat and electricity flowing through that wire. So you cannot. So immediately you must repair or replace immediately or throw it away. Okay. Of course, they didn't write here throw it away. You can repair, replace. Replace means throw it away. Throw and buy new one. Correct. So which one are following? So A is definitely correct. Touch exposed wire with that hand. Definitely wrong. Cannot go and do this. Do not put too many plugs in one socket. Correct. Because too much, you are overloading. Okay. There's a chance for fire to occur because you are trying to heat up too many or trying to get electricity to go through to too many appliances. So it's going to generate an over power supply. Okay. And then always keep the area near wires dry. Of course. Okay. So you got A, C, and D. Answer is D. Fine. Okay. So we need to know how to be safe and we need to know how to connect electricity and how the batteries function. And also we learn one important thing about the GPS, about going to Vivo City and the roadblock. So that is going to be in your memory for quite a long time. Okay, I know that because it is in mine. All right. Then these are all easy questions. They are not MCQ, so it'll take a little bit longer to discuss, but I will post the answers on the wherever you got these questions, right? Like before the lesson, you got the question. After the lesson also, you get the after class notes. Where you download again, you get all the answers to this. So you actually go and try it on your own based on today's lesson. And you will find the answers and you can check. That's the better way to learn, right? You cannot always sit here and what's the point of me going for another half an hour and teaching you the same thing, doing the same thing when you haven't done? So you go try, and then you will find the answers anyway, and then you will be able to clarify. Of course, you can always ask me questions. I've given you my contact number. You can go to the 88Tuition website and type a question, and I will get the question. I will try to get back to you. You can ask for my number. You can go to all the lessons, because next week, I'm not sure if this class is going to continue, because we are going to allow your school to take over fully, because your school is going to open fully, right? No more HBL. Next week is the last HBL. And after that, we know you're going to be busy with school. You don't want to always come here at 4:30, and then you don't need to, because you can go to 88Tuition website anytime. I'm always there at any time. My face is there teaching all this stuff 24 hours a day. You can on me at 12 midnight, like I said at the start of the class. Some of you like to study at 12 midnight. Some of you start studying on the weekends at 5 a.m. I will still be there. Mr. Ali, no matter what, he'll be still on the website teaching electricity, living things, whatever topic you want to know is there. Full syllabus from primary 3 to primary 6 is there already. You just click and I'm there teaching these same questions, the same way, the same energy, the same person, the same jokes, all that. But I don't need to come here exactly at 4:30 on Wednesday and then be tired. Actually, I'm sleepy, mommy. I cannot attend the class. No need, because you sleep, then you wake up, then you go, 88Tuition, let's do magnets now, and then you do. Because you can do anything that you have been doing in school. Okay? Because the problem is also that all of us here are all friends already now, but we know each other. But all of us are doing different topics in school, and then it's a bit of confusing mixing, right? So not very, very productive. Productive is whatever topic you are doing in school, say if it's electricity, go to the 88Tuition, say, Ali, where are you? Come here. Press electricity, I'm there teaching you electricity, and you do questions and you learn. Okay? So I'll see you all back on the website, and you can also still get the questions there whenever you want me. I will try and respond to you. Great. See you guys. soon. Of course, I will miss you all, but I will still be in touch through the website. Website will be there forever. All right. Bye-bye.